Creating day 0, day 1, or even day 2 configurations tailored to customer-specific environments has always been a complex and time-consuming challenge. My name is György Szakács, Head of Delivery Automation Tools, and in this demo, I will show how AI can help to eliminate this burden, transferring manual, complex design processes into automated, intelligent flows. We will explore how existing customer documentation, reference project files, and large language model can be combined to bring real efficiency and consistency into design configuration generation. As we look at the current state of configuration design in large-scale deployments, the challenges are clear. Configurations are complex, and many of the design processes are still manual or only partially automated. At Nokia, we are addressing these issues by introducing AI-powered solutions. We leverage AI and machine learning to identify design intents based on the available customer documentation. Then we use large language models to automatically generate both the CIQ and the configurations itself. And finally, we validate the generated artifacts, ensuring consistency and accuracy. The outcome for customers is simple: faster design cycles, fewer errors, and a digitalized configuration flow. Our intention is to simplify manual tasks by reducing the number of customer-facing parameters, making the deployment configuration process more efficient. What you will see is design intents are generated from customer documentations, where some of these intents are then converted into CMG or CMM deployment configurations through a table-based or an iterative method. Also, for some selected design intents, XML configuration is created that accurately reflects the required change. At the end, we validate the generated artifacts and provide the final deployment configurations or the generated XML samples to the orchestrator for execution. This architecture shows how large language models is used for this solution. At first, we prepared the RAG databases by indexing customer documentation and young models and listing the available design intents on the user interface. Then process starts with a design engineer selecting a configuration intent via the web interface. The system then searches customer documentation and young models indexed in these databases to extract the relevant CLI commands and parameters. Then the language model combines these data to generate an initial XML configuration and the customer information questionnaire form for user input. The user fills the required parameters or uses the default values, and the system produces the final configuration ready for deployment. Now let's see how it looks like in real life. Let me share the list of intents, what's available for the CMG product, generated from the customer documentation. First, let me initiate the CIQ generation for the CMG product. This will take time since the allocated GPU is restricting our bandwidth. In the meantime, I can also start the iterative mode. Let me select then the CMG latest version and start the iterative mode. Here the system will ask me questions which I need to respond. The first question is that what's the name of the UPF I would like to deploy? Let me give it. It digesting the input and asking the next question. It should be the namespace. What's the namespace I would like to deploy it? Then for the rest of the questions, I would like the system to use the reference values. And here the system will start generating the final deployment file. Let's see the table view. Here you can see that the CQI table has been generated, where I can use the reference values and immediately mapped to this column. Here now I can modify some of these. Let's see some of the IP addresses I change. And generate the final YARN file for deployment. Here in the iterative mode, you can see that the system has already started the final deployment file generation using the reference values. In the next tab, let me show then how a selected intent can be created. Let's pick again a CMG, and for example, an easy one, the HTTP2 profile configuration. It's much easier and faster since that requires only 3 parameters to check. I can use the reference values and generate the configuration file. After this is generated, I can validate the configuration, I can download the configuration, and even I could apply this configuration, meaning that it could be sent to the Nokia orchestrator, the Encom Evo. This automation significantly reduces manual effort and speeds up the design phase during the network setup. Thank you.